Welcome back. In this segment, we will discuss types of bending operations. Perhaps the most important type or most commonly used type of bending is V bending. It is performed with a V shaped die and a wedge shaped point to force the metal into the die. The included angle of the V bend can be changed by varying the distance the punch forces the sheet metal into the V die. So we will see this point in the video as well as in one of the figures in the following slides. The V bending is used for low production. It is generally performed on a press brake, and V dies are simple and inexpensive, and they are easy to use. So there are further two types of V bending. When the punch does not bottom out, the process is referred to as air bending. In air bending, the material being formed contacts only at the point of the punch and two edges of the V die opening. So this is one point of contact that is between punch and the sheet, and sheet contacts the die at 2 points. Now, by changing this depth of the blank that it moves into the die, we can make different angles using the same die. So this is the point that the included angle of the V bend can be changed by varying the distance the punch forces the sheet metal into the die. So using the same die, we can make different angles by controlling the distance that this blank moves into the die. So this is air bending because there is some gap between the sheet and the bottom of the die. It is not bottoming out. Then we have bottoming die. When the punch is allowed to bottom out in the V bend die, it is called the bottoming die. So you could see the punch, the die, and the starting blank, and it is squeezed into the die. So this is called bottoming operation or V bending using bottoming. Then we have edge bending. This is also called cantilever bending. The workpiece is clamped to a die block by a spring-loaded pressure pad. So this is the pressure pad that is holding this blank using a certain force. The punch wipes the extended material over one edge. So this is the punch. So this wipes this free end of the blank on this edge of the die, something like this. It is used for high production, and dies are more complicated and costly. Then there are many other types of bending operation that are essentially a variation of the basic operations. One of them is flanging, a bending operation in which the edge of a sheet metal part is bent at 90 degrees. But the portion that is bent, the length that is bent is small as compared to total length of the part. So that is flanging. So it is a 90-degree bend, but the bent portion is small as compared to the overall length of the part. It is often used to strengthen or stiffen the sheet metal. So you could see that the flanging could be straight flanging, just like this. This is a straight bend. The bent part is straight. It could be stretch flanging. So you could see a curve is being made. Here as well, a curve is being made. So depending upon the shape of the curve, whether it is concave or convex, it is called stretch flanging or shrink flanging. Then we are having hemming operation. It is also called flattening. It involves bending the edge of the sheet over on itself. So it is basically 180-degree bend. Usually performed in more than one step because a lot of deformation takes place. It is used to eliminate the sharp edge on the workpiece or to increase the stiffness and to improve the appearance. So you could see that this is the hemmed part. So this portion has been bent to 180 degrees. There is an operation that is called curling. It is similar to flanging, but the bent portion is in a curved pattern. So it is also called beading, and it forms the edges of the part into a roll or curl. So the name curling. It is done for purposes of safety, strength, and aesthetics. So this is the curled portion of the part. Then we have staking. It is a method of fastening sheet metal by squeezing protrusion formed in one part inside a hole in the second part and then deforming the protrusion. So this part, upper part, had you can say some slots through which this second part was extended, and then these protruded parts or extended parts were bent. So these uh, two pieces of metal, one and two, were assembled together. So it is a method of fastening sheet metal by squeezing protrusions. So these are two protrusions. These two pieces, A and B. So by squeezing the protrusion formed in one part inside a hole in the second part and then deforming the protrusion. So in this case, this part one is having the hole and two portions of part two are extended through that hole and then bent. So this is called staking operation. Now we will see these operations, some of these bending operations with the help of a video. So here you could see the bending operation is being performed. So the point where the punch contacts the sheet is the layout line. That line is the layout line, and you could see the gauge that is actually helping us to position the blank in the required position so that the bend is made at the required point. So the force applied should be greater than the yield point of the metal being deformed. So this gauge is acting as a reference gauge. You could notice that this is a V die that is being used. And you could notice the shape of the punch as well. So this is another example. So V die and the shape of the punch could also be noticed, and you could also visualize the position where the punch is contacting the blank. So that is the layout line. So force being applied should be between the yield point and ultimate tensile strength of the metal being deformed. And outer fibers are being stretched, and the inner fibers where actually punch contacts the blank, they are being compressed. And then there is a neutral axis or neutral bending line. Ductility of the metal is important for bending operations, especially for the larger bends. And you could see again, here is the V bending die, and this is the punch. And the bending operation has been performed. Important process parameters are bend allowance, bend angle, bend radius, and spring back, as we have already discussed. So you have to make a radius, so that radius should be converted into a straight length of the blank. So that is the bend allowance. So some people call this angle to be the bend angle, but we have taken the outer angle, the angle through which the metal is being bent, to be the bend angle. So that is the convention that we followed. And there is the bend radius. So in the calculation that we made, the inner radius was taken to be the bend radius. The spring back is increase in the included angle or decrease in the bend angle. So that should be uh, catered for as well in the case of bending operations. Now we will watch another video where we will see other bending operation like flanging and hemming. So flanging, that is bending the edge of a sheet to 90 degrees. So you could see the length of the bent portion is smaller as compared to the overall length of the part. So that is flanging. So this is the flanged part. So it could be a straight or stretched portion. So the purpose of flanging include the ones that are mentioned: part appearance, part rigidity, edge strengthening, or removal of a sheared edge, or fastening surfaces to provide a surface of fastening. And this is the hemming operation. So you could notice the 180-degree bend. This one, this portion is bent to 180 degrees. So hem could be a flat hem for more ductile materials, or it could be a teardrop hem for relatively less ductile materials. Or it could be open hem to join two parts. Open hem and rope hem are used to join two parts.